Alright, our last chapter, chapter 6. Actually, we're not even doing the whole chapter, just part of it. So we're going to be talking about the area between two curves. So we talked before in chapter 4 about how an integral can be used to find an area, or an area can be used to represent an integral. So the area underneath that curve would be that. Now, this curve would be down here below there, and so we could find the area of this curve. And if we subtract those two things, we'll get the area in between those two curves. And so what we can do is combine those two and actually take g of f minus f of x inside that one integral and do it that way. Okay. So let's try that out with a problem. So it says find the area of the region. So as soon as you see area, that tells you that we're finding an integral. Okay. So we're going to start with the line y equals x plus 6. So 1, 2, 3, 4, 5, 6 is the y-intercept, and the slope is 1. So that's going to take us up here. Hopefully you're excited that this is our last part of a chapter, chapter 6. And there's our top function. And that's another thing we could kind of think here is it's going to be the top minus the bottom. We're going to use that for a few different things. Alright. And we have a parabola shifted up 4. So 1, 2, 3, 4. And normally when a equals 1, the parabola goes over 1, up 1, over 1, up 3. Same thing here. So there's our parabola. And the last thing here is that it also says that we're going from 0 to 1. So that's a little bit different. Well, I'll talk about that later. So 0 to 1 is right here to right here. Okay, so 0 to 1, and we take the top, which was x plus 6, minus the bottom, which was x squared plus 4. Alright, so if we distribute that, that would be negative x squared plus x. 6 minus 4 is plus 2. So now if we integrate that, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent, plus x, from 0 to 1. So if we plug 1 in there, we're going to get negative 1/3, plus 1/2, plus 2, minus, and plugging 0 in all those, they all are going to be 0. So now let's get a common denominator here. So that common denominator is going to be 6. So this needs to be multiplied by 2 over 2. So that's going to be negative 2. This needs to be multiplied by 3 over 3. And this needs to be multiplied by 6 over 6. That's going to be 12. So that's going to be 13 over 6. So that's the area. So if you look at that, that's about 2 and 1. That's 2 and 1/6. And there's 1. And you see that it's a little bit more than 2 squares, which would make sense, 2 and 1/6. Okay. Now this next question asks us to find the area of the region bounded by those graphs. And so what we would want to do is find the points of intersection. Okay. Now, these happen to be the same equations as we have in example 1, so we could actually just look at the graph. But let's say that we didn't have that graph, and so what we would do is we'd want to find out where these intersect, we set them equal to each other. So it would look like that. So if we subtract this over here and factor that, 1 and 2, negative and positive. So what we want is x equals -1 and 2. So that gives us our limits of integration. So we're going to go from -1 to 2. And we still have the... Now let's just say we didn't have that graph, because we can look at that graph and figure out what's on the top and the bottom in that section. But let's say we have top or bottom question mark. So what we can use is we can do a test point. Okay, so, and we need a test point in this interval. So we need to be in the interval from -2 to 1. So let's try x equals 0. So if we put f of 0 in here, we get 6. And if we put, g of 0, that's going to be 4. So that tells us 6 is above 4, so that tells us f is on top. Alright, now, so we need to have f minus g, so that's going to turn out to be the same thing we had up there. So it's going to be x plus 6 minus this, so that's going to be minus x squared, and then plus x, and then this minus this plus 2. Okay, so we integrate that, we're going to get the same thing we got up there, but you could just do it again. Hopefully it's not a big deal. And this time we're going from -1 to 2. So that's going to be, now we're going to have to plug that in. So when we plugged in, we're going to need to plug in 2. So 2 cubed is 8, so that's going to be -8 thirds. 2 squared is 4 over 2, that's going to be 2 plus 4 minus, plug in -1 in here, it's going to be a negative times negative is positive, so that's going to be 1/3. -1 here squared is 1, that's going to be 1/2. And -1 here, that's going to be -2. Now you do have to distribute this negative all the way across there. So now we have -8 thirds minus 1/3, that's going to be -9 thirds. Okay, -9 thirds. And then this is 6 minus, well, let's do this, minus 1/2. And then this is going to be 6 minus a -2, so 6 plus 2, so that's 8. Okay, so this is -3, so that's 5 minus 1/2. So that's going to be 4.5, 4.5, 9 over 2, any of those. Okay, before we go to the next page, I've got a couple of, it's getting closer to Valentine's Day for those of you who celebrate that event or whatever. So here's a little cartoon. He says, can you solve this? Actually, I think he should say simplify. Can you simplify this? And she says, no, I can't. And he goes, oh, let me erase it. And then she gets mad because she's like, well, you just explain it to me. But when he erases it, he just erases the top half of it, and then Annie has a flower hidden somewhere. And she goes, oh, that's cute. Okay. And one more thing you can try. Text this to somebody. And if they can't figure it out, then maybe you should choose somebody new. Anyway, so if you text that to them, then maybe they will divide both sides by 2, and then maybe they will respond. Maybe they'll respond, I is less than 3u. And then you respond, this would be them, they respond, and then you respond. they would respond, and you respond, I love you too. And guys, make sure you use the right to, because the ladies don't like it if your English skills are bad. So that's a homophone. Homophone? Phone? Homophone. Sounds the same. Two, and two. There and there, your and your. Anyway, so there you go. Hopefully that was amusing to you. Okay, let's move on here. So we want to look at the sine and cosine curves, and they intersect infinitely many times. So it says find the area of one of those regions. So probably the first thing we should do is maybe graph these. So I'll call that 1 and -1. And I'm going to call this 2 pi over here. So I'm going by pi over 2. So sine starts at 0, 0, and it goes to pi over 2, 1. It comes back down. So when I graph my trig functions, I always divide it into 4 and then graph from there. So this would kind of go like this, and kind of down here, like that. I don't want to cut through my 1 there, so I'm just doing that, and then that's a little bit pointy there, but get the idea. So there's my graph of sine, and I'm going to graph cosine. So cosine starts at 0, 1, and then comes down here like so, and here, and here, and here. So kind of like that, and down, up, and like that. So here's one of those sections. Alright, so we can look at that, and so we're going to integrate, and the section I chose looks like the blue is sine, so sine's on top. So we're going to have the sine of x minus the cosine of x. And the next thing is, you remember we want to find the points of intersection. So I believe on the last one I said set those equal to each other. So we'd have sine of x equals cosine x. Now, when you're solving trig functions up here, if you remember from maybe your last year or two, you either want to get it to be a product or you want to get a single trig function identity. So if your first thought might be like subtract cosine over, then you have sine minus cosine equals 0. That's a little bit awkward. That's not a product, and it's two different trig functions. So instead, what we could do is divide both sides by cosine. So if we divide both sides by cosine, we get this. Now, we could change that to multiplication and do 1 over cosine times sine, but we also could just switch that to tangent. And what that does is now we're down to one trig function. And so the question we're asking is, when does the tangent equal 1? And the tangent equals 1 here in the first quadrant, which is pi over 4. And then again in the third quadrant, because you get negative root 2 over 2 over negative root 2 over 2. So that's 5 pi over 4. So I imagine that's a little bit tricky for some, how much trig stuff you had, but figuring out those values. So if we integrate that, if we integrate sine, we get negative cosine. Remember, to check, you can just take the derivative real fast. So the derivative of cosine is negative sine. So since that's positive, this must have been a negative cosine. So I took the derivative of this, I got negative sine, and negative would be positive. Here, this is going to be negative sine, because the derivative of sine is cosine. And so to keep it negative, then this has to be negative. And we're going from pi over 4 to 5 pi over 4. So to do that, we plug in 5 pi over 4 first. You want to factor that out? So I have negative cosine 5 pi over 4 plus sine 5 pi over 4, because I factored out that negative 1. and then we would have minus, and then we would have minus this. But that has a negative in it, both those, so if I factor that negative out, so that's going to become plus, actually. And now I'm going to have cosine of pi over 4 and plus sine of pi over 4. Okay, so this 5 pi over 4, cosine of 5 pi over 4, 5 pi over 4 is down here. And that's basically 45 degrees. So that's negative root 2 over 2. And sine of 5 pi over 4, that's also negative. So that's going to be plus a negative, or just negative, root 2 over 2. Okay? And over here, pi over 4, that's in the first quadrant. That's root 2 over 2. And this is root 2 over 2. So, distributing this, that's all positive. So basically, we have root 2 over 2 plus root 2 over 2. That's 2 root 2 over 2, which is just root 2. So we're going to have root 2 and plus root 2. So that's going to be 2 root 2 for the area between those two. So this is, we got these two graphs here. We can graph the line first, I guess. Looks the y-intercept would be negative 12. 12, and the slope is 1. So there we go with that. Now the parabola, we see it's squared. We see that a equals 1. So we could let's find the vertex and see what we can do with that. So remember, the vertex is the opposite of b over 2a. Alright, so it looks a little bit like a 6, but it's a b. So that's going to be the opposite of negative 5 over 2 times a. So that's going to be 5 halves. So the x-coordinate of the vertex is 5 halves. So not really excited about that. So maybe we can just think about that. So 5 halves is the vertex. So let's try maybe 2, 1, 0. Because these numbers are smaller, it'll be easier to plug in to see what's going on there. So if we plug 2 in here, 2 squared is 4. And 4 minus 10 is negative 6, and negative 6 minus 7 is negative 13. If we plug a 1 in there, we're going to get negative 12 plus 1, that's negative 11. If we plug 0 in there, we're going to get negative 7. If we plug negative 1 in there, we're going to get 1 plus 5, which is 6 minus 7, which is negative 1. So negative 1 is right here, and then negative 1, 2, 3, 4, 5, 6, 7 is here, and then 8, 9, 10, 11. Looks like 11 is right there, and then 12, 13 is right here. Now that's 2, negative 13. Now the axis of symmetry would be at 2.5. So I'll mark that on here. And they're not going to have you do all this because it's taking too long. So usually, I think they usually give you the graph when they ask you one of these, but we'll see. So now, still good practice for us. We're supposed to know some of this stuff. So we can reflect this over here, and we should be able to get those points there. So down here somewhere is that vertex, which might not be that big of a deal. So we're trying to find the area between the two curves. Now they tell us to go from negative 1 to 5. But now as you look at that, you hopefully realize that we have some issues. So negative 1 is right here, and 5 is over there. So if we look at that, well, maybe somebody could, if we were in class, I would say, well, what, does anybody notice something that's different about this one compared to the other ones we've done? Color with this big highlighter here. This looks like that smudged a little bit with the ink there. Looks kind of artistic, maybe, or maybe not. Anyway, alright, so what we have is that what's happening is that what's on top and what's on the bottom is changing. So we're actually going to have to break this up into two parts. So this first one is going from negative 1 to 1. And in that one, the parabola is on top, so that's going to be x squared minus 5x minus 7 minus, and you got to be careful here, you got to put this in parentheses, x minus 12. Okay, I don't know if I left myself enough room here, but, and then from 1 to 5, those are going to switch, so we're going to have, I guess I don't need a parenthesis on that actually. X minus 12 will be on top, the red line there, minus, and now that's what needs parentheses, the parabola, so x squared minus 5x minus 7. Okay, should scoot that over a little bit. Okay, so if we simplify a little bit here, we have x squared, and then we have minus 6x. This is plus 12, so that's going to be plus 5. And might as well maybe do a little bit of work over here also. So this is going to be negative x squared. That's plus 6x. And this is negative 12 plus 7, so that's going to be negative 5. Okay. So here, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by 2, and 5x. And that's from negative 1 to 1. And then over here, we're going to have negative 1/3 plus 3x squared minus 5x. And again, you can take the derivative of that to check to make sure it equals that. You can do that pretty quickly. So if we plug a 1 in there, that's going to be 1/3 minus 3 plus 5 minus, use that parentheses, negative 1/3 minus 3 minus 5. So that's going to be 2/3, and this is 2, and that's minus a negative 8. So 2 plus 8, that's going to be 10 when we put all that together. Okay, now over here, what are we going to get? We're going to get 5 cubes. That's going to be negative 125 over 3. And then 25 times 3 is 75. And then minus 25. And I don't know if I have enough room. Minus, parentheses, plug in a 1, so we get negative 1/3 plus 3 minus 5. So, plus, that's going to be plus 1/3, so that's going to be negative 124 over 3. And this is going to be 50 plus 2, so that's going to be 52. Okay. So if we put these together, that's negative 122 over 3, and this is going to be 62, so to get a common denominator, 62 times 3 is 186, and so that's 64 over 3. Alright, now when you look at this, your first thought should be that it looks a little awkward, and you notice that both of these equations are solved for x. So if we think about that, if we were to subtract 2, we could have y equals x minus 2. So the y-intercept is negative 2, and the slope is 1. So that actually would be right here. And then if we look at the, and so we could have looked at that, like I just said, as y equals x minus 2. This other one's a sideways parabola, so the vertex is 0, 0, and it goes like this. So and we're looking at that region between those two. Alright, so what we can do here is we can look at this from a different point of view. So kind of like that, but what I'd rather do is if it was transparent, I could flip that over, because that's a little confusing for some students. Because you have to remember, if we flip it like this, this is our negative y value down here. This is negative 2. This is negative 1. This is positive 1. This is positive 2. So when we look at this graph, we have to realize that it's kind of going in reverse of what we would normally think of. And so what we can do here is say what's on top and what's on the bottom and where are they going from. So you see here that we're going from negative 1 to positive 2, hopefully. So if we integrate from negative 1 to positive 2, what was on top was the line. So that's going to be y plus 2. And what was on the bottom was the parabola. So that's going to be y squared. And so this is going to be dy. So we're doing this in terms of y. Okay. So I'm going to just integrate that. I'm going to put it in order though. So that's going to be y cubed, and that'll be negative 1/3 y cubed, and then plus 1/2 y squared plus 2y. And that's going from negative 1 to 2. Okay, so we can plug 2 in there. We're going to get negative 8/3 plus 2 plus 4 minus, and then we can plug in negative 1, so that would be negative 1 times, that would be positive 1/3, and then plus 1/2, and then negative 2, like so. And so putting all this together here, that's going to be negative 9/3, 6 plus 2 is 8, and minus 1/2. So that's negative 3 plus 8 is 5, 5 minus. So that's very, it kind of matches the problem we did on the front there a little bit. So that's going to be 4.5. Okay, now the other way we could do that is kind of awkward. So what we could do is realize we could look here and we could just do it like we were doing before. So we could say, okay, well, from 0 to 1, the parabola is on top, and we could solve those for y. So that would be y equals the square root of x, and this would be, I don't think anybody would ever do it this way, but I mean, we could. So this one would be from 0 to 1, we have the square root of x, the top, minus the bottom. Okay, so we would have that, and then starting at 1 over here to 4, we still have the parabola on top, so that would be the square root of x, but now the bottom would be the line, and so we would subtract, and we switch those to x, and so we would do that. And so if you could do this, and you should get 4.5 also. So you see that's kind of a lot more work. That was off the screen a little bit there. That's awkward. Okay. Any questions on any of that? So we actually do have a little review question here at the end here. So let's take a look at that real fast. So let R be the region enclosed by this graph and the horizontal line. Oh, here's the axis, and that's the line y equals 4 there. So the vertical line x equals k divides the region into 2 equal areas. So you just approximate that over here somewhere. So that's going to be k. Alright. And I kind of missed a little bit. Well, maybe. Looks like this is bigger, but it's supposed to be in the middle. Okay. So it says, write but do not solve an equation involving integral expressions whose solution gives the value of k. So what you could do here is, if you set that set them equal to each other to focus in on these 2 points right here. Subtract 4 from both sides, that would be 0, and then we could factor out an x cubed, so this would be x minus 2.3. So this point is going to be 0, 4, and this point over here is going to be 2.34. Alright, so what we should have is the integral from 0 to k, and that's going to be the top, which is 4, minus the bottom. And what we want to do on an AP test, on the free response, is we want to make sure we use, instead of writing that out, let's just use f of x. Okay? So this gives us the area of this side. And it's saying that that line is cutting them in half, so they should be equal. So that should match up to k to 2.3. And we also have 4 is still on top, the horizontal line, y equals 4. And the function is still on the bottom. And there we go. That's it. That's the answer. So those are multi-part questions. I left off part A and B because the notes are already long and you need to review those, but I don't have the year for that question on there. But here's another one, the 2017 AP test. So if we read through this quickly here, let's see. 2 particles move along the x-axis. We're going from 0 to 8. The position of the particle is given by this. So we can tell it's a position function. The velocity, okay, so that's v of q, so we can see that. And we have this initial condition here also. So we want to make sure that we pay attention to that. So that's 0, 5. So we've kind of looked at all of those. So it says for those values, when is p moving to the left? Okay, so right away, moving to the left, we know that we should be putting, because v of p is less than 0. That's when the particle would be moving to the left when the velocity was negative. Okay, so to get the velocity of particle p, we're going to integrate, or take the derivative, sorry, we're going to take the derivative of this. So the derivative of the natural log is 1 over u times du. du would be 2t minus 2. 2t minus 2, I could factor a 2 out of that, so that would be 2 times t minus 1. Now if you look at this from 0 to 8, this is always going to be positive. So because we have this plus 10 here, so 0, you plug in 0, it's 10. If you plug in 1, that's going to be 9. If you plug in 2, it's going to be 10. If you plug in 3, once you start plugging in 3, 4, 5, 6, this is bigger than that. So this is always positive. So all we have to do is look at that part. So if we look at that part, the number is, so we have 0, we have 1, and we're going up to 8. So if we look at this from 1/2, we plug a 1/2 in there, that's going to be negative, and then all this is going to be positive. So that is moving to the left from 0 to 1 because the velocity is negative. Okay. Now, it says find all the times where they're moving in the same direction. So this, we have this velocity formula here already, so we can factor that. That's already velocity. So t and t, and this is positive, so they have to have the same sign, and the 8 is negative, so they both need to be negative, and pretty easily 3 and 5. So if we look at this one, it's going to be 3, I need to be careful here, and 5. Didn't really space that out properly, but hopefully it's enough I can tell what's going on. So 2, for example, 2, this is negative, and negative times a negative is positive. So that would be positive. And then 4, that would be positive, but this would be negative. So if we multiply those together, that would be negative, and 6, they'd both be positive. So when is it moving in the same direction? It's when they have the same sign. So from 1 to 3, see, this is positive up to 3, and that starts being positive at 1. So 1 to 3, and then again from 5 to 8. Okay, because V of P and V of Q have same signs. So that would be our reason for that. Okay, we got to have those reasons, those calculus reasons, because, over and over again, so try to emphasize that. Alright, find the acceleration of particle Q. So that would be the derivative of the velocity. So the acceleration at Q is going to be 2t minus 8. Okay, and so if we so the acceleration of Q at 2, if we plug 2 in here, is -4. So it says, is the speed of the particle increasing, decreasing, or neither at time equals 2? Explain your reasoning. So here we have the acceleration of Q is -4 at 2, and the velocity, that's the red right here, at 2 is positive. Okay, so V of Q at 2 is positive. So we're going to say the speed is decreasing at x equals 2 because A of Q and V of Q have opposite signs. Because. So notice all those becauses. It's very important. Alright, finally, last one. Find the position of the particle. So we had this on our first test. Find the position when the particle changes direction, particle Q. So particle Q is going to change direction when the velocity changes sign. So that's at 3. So that's at t equals 3 because v of q changes signs. So we need 0 to 3, find the position. So we need to integrate velocity. So we're integrating the velocity of q like so, and that's going to be the position of q at 3 minus the position of q at 0, which they gave us up here. That's 5. And we're solving for this, so we need to take this and add 5 to it. So q is right here, so we're integrating this. So that's going to be 1/3 t cubed minus t squared divided by 2, so 8 divided by 2 is 4, and then 15t from 0 to 3 equals our position at 3 of q minus 5, and add 5 to both sides. So this is the change in position, both of these. Change in position. This was the initial position. Alright, so let's wrap this up. So plugging 3 in there, 3 cubed over 3 is 3 squared, which is 9, minus 36 plus 45, minus 0, add the 5 over. So that's going to be, that's 9, so 9 plus 9 is 18. Oh, but yeah, on the real AP test, we would just box that. But I still, 1823. Okay, it's about that time. Have a good day.